Don't use them. You can wait for a couple of seconds so we can. Hey everybody, welcome to the webinar on IoT on the Paintshop. We'll wait for a few more minutes for rest of the attendees to join in. Till then, kindly wait for a couple of minutes.
So you'll have to ask questions. Okay.
Am I audible? Can somebody confirm from the participants? Yes. Great. So, without much ado, let's dive in. Good morning, everybody, and welcome to the webinar on IoT and data analytics for Paintshop. I'm your host, Ekta Upadhyay from Silent Technologies. We are a value-added partner for Instron Technologies for the industrial IoT solutions. Well, we have a full house today, so we will begin with addressing the audience on the importance of paint shop automation by Dhananjay Khon, BDM Instron Technologies, followed by expert speakers, Mr. Mauritius Sapre, Senior Manager Maintenance and Project Sigma Engineering Solutions, Mr. Ramesh Chavan, Senior GM Manufacturing and Lean Coil, and a panel discussion led by Mr. Sharad Jadhav, Manager Paint Shop Intuos Technologies, and Mr. Ian Saldana, Managing Partner Rohan Standoff Autolab on their journey in IoT. The topic today here is directly linked to quality. Any deviation in the paint shop KPIs can lead to rework and rejections. But how does one control the outcome? This is the challenge we will address today. Now, without much ado, let's take a deep dive with our industry experts, subject matter experts, who will share their journey with us and guide us on navigating the challenges. With a quick introduction about Dhananjay, he is an MBA grad from Nursing, and his core competency lies in the business understanding on automotive and textile sector, as well as process industry, having worked with OEMs like Lab, Leone Cable, Weldon, and Secure Meters. Over to you, DK.
Thanks, Ekta, for your nice words. Good morning, everyone. I am thrilled to hear today myself, Dhananjay, and I'm taking you to brief introduction of Instron Technologies with following with the corporate video. We are 10-year trusted name in the industrial automation and the process industry. With a vision to be known face in specialized products and solutions in the area of automation, process plant design, and IoT systems, we have successfully delivered 200 plus installations worldwide. Why? Because we have expert automation service provider company. Our innovative automation solutions dedicated to improve overall productivity, operational efficiency, product quality, and equipment safety. With this, I will take you to video which give you more insight about Instron technology. Ankita, please start the video.
Products and solutions for domestic and international customers, for manufacturing industry, for process industry, and also research laboratories. And we could do this because of our in-house cross-domain expertise, rich experience, and dynamic. Hello, I'm Vijay Sainavi. Hi, I'm Rahul. Hi, my name is Rahul Shuri. I have 19 plus years of experience in research, product development, and Internet of Things. More than years of experience in process engineering, automation solutions, and new product development. With me, I bring 30 years of experience in automation and IoT new product development. Instron was incorporated as a proprietor firm in 2013 and Instron Technologies LLP was formed in 2016. Based out of industrial hub of Pune, Maharashtra, we have served 200 plus reputed clientele, and now we have incorporated Instron Technologies in Canada to serve the North American market. This makes us MNC with Indian origin. Instron Technologies offers products and solutions into three verticals: process plants, digital factory solutions, and test systems. In process plants, we help customers right from conceptualization to detailed engineering and also complete plant supply and installation. In digital factory solutions, we help customers monitor their critical parameters on the go by offering systems right from sensors, communication with existing PLCs, and then giving authenticate data to empower the decision makers. And in test bench systems, we provide end-of-line and performance evaluation test benches for, say, electrical motors, appliances like refrigerators and ACs and thrusters, etc. Our strength is our in-house expertise in automation, IT, chemical processes, and mechanical design. We leverage it to discover unmet customer needs and provide turnkey tailor-made solutions. Our solutions have helped clients to enhance their production and efficiency to achieve their sustainability goals. In order to accomplish our motto, let's grow together, we strive to foster a family-like environment within our organization. This has added in strengthening the bonds between team members, instilling a sense of responsibility for all we accomplish and increasing employee retention over time. We at Instron Technologies here innovate to improvise operations of customers worldwide in manufacturing industry, process industry, along with the research laboratories. To be a known face in specialized products and solutions in Indian industry, in process plant systems, and digital factory solutions, and test bench systems. We offer integrated solutions for various industries. We have been recognized as one of the 10 most promising industrial lot solution providers. We are ISO certified, and we also got selected for DRDO Technology Development Fund and Index Initiative. With this, we look forward to expand our expertise in Canada, Australia, Sri Lanka, and Thailand. We have developed a young and dynamic core team and execution teams to help achieve the organizational goals. We strive to achieve the philosophy of growth at individual level and also at organizational level. Because of this, we have leaders in our organization quote day-to-day decisions.
Great to see Instron winning so many accolades globally. Let's hear it now from Mr. Milind Selne, founder of Instron Technologies. And alumnus of IIT Bombay, Milind is a seasoned business leader in the energy engineering IT sector, helping customers achieve revenue growth and productivity. Over to you, Milind.
IoT. Yeah. Good morning, all. First of all, thank you to all of you for giving your valuable time to listen to our practices on IoT. Just give me a minute till the time we bring our screen online. Yeah, I hope my slides are visible to you. Okay. There is, okay. You can see the slides, right? Okay. Yeah. Today we are going to take you through the IoT and data analytics for the paint shops. Next slide. Yeah. So coming to the point why today we want to focus on the paint shop, even though we have delivered so many successful cases for machine shop, foundries, and many other process industries, but still we today wanted to focus this whole discussion on the paint shop. The reason being, few of the industry experts that we heard of, for example, Mr. Deepak Patil, manager paint process from Sigma Electric. What he says is paint shop is a special process in the manufacturing industries, and its outcome is dependent on multiple KPIs, few to mention like pH, conductivity, temperature, velocity, etc. Any deviation in these KPIs can lead to rework or rejections to the tune of 5 to 40%. Hence, to get the desired results on quality front, it is necessary to monitor, alert, and auto control KPIs to achieve the desired outcome. So this was on the quality front, as you can see. There is one more industry expert who is anonymous, and he is the general manager in an auto component manufacturing company. So in manufacturing industries, paint shop account for 15 to 25% of operating expenses. Hence, along with quality, it is important to monitor and control cost. So as you can see, there is a balance of quality as well as the cost part of it. And that's why we thought of taking today's discussion around the paint shops, how the latest trends and technologies can help the users to improve their paint shops. So to start with, we wanted to highlight the different types of paint shops that we have came across. Typically, we try to distinguish these paint shops in continuous process or batch process. The difference is in continuous process, the components to be painted are mounted on the conveyors and they flow seamlessly from the first tank of the pre-treatment to the last tank of the pre-treatment, and from there it goes to the water drying oven, painting, and then baking oven. As against that, in the batch process, it's a basket in which all these paint components are mounted, placed, and then this basket is moved from one place, one tank to the second to third in a predefined sequence. And as usual, after that, there is a water drying, painting, and oven, depending on the process that particular company goes through. So these are the two major differences, or two types of the paint shop. Apart from that, the other classification criteria could be the liquid or powder to be used for the paint shops, the material on which the paint is to be coated, which is the metal or plastic, and one more criteria could be whether it is a plating or painting. So having, yes, of course, there may be many other types, but having said about these different types, what we are trying to say is we have gone through all these different types of paint shops, and what we have understood is what are the critical parameters for the paint shop. So as you can see that paint shop can be classified into three segments: pre-treatment section, painting section, and baking oven section. And for all of this, the critical parameters can be divided further into quality parameters, costing parameters like the utility, and the productivity parameters. As you can see that for paint, which is aesthetically important and quality is the first and foremost parameters, we have taken it in the first in the sequence. So for example, in the pre-treatment section, what is important from the quality point of view is pH, conductivity, temperature. If it is a batch process, then it is dip time. And if it is a continuous process, then it is the water spray pressure. These are few of the parameters. There could be many more varying from customer to customer based on their pain points. But moving on to painting operation, the critical parameter from the quality point of view is air pressure and gun program. For the baking oven, it could be the temperature of oven, conveyor speed, and temperature of the flue gas. So these are the quality parameters. I'm sure that most of you will agree that one or two of these are applicable for all of you, and there could be few more. But apart from the quality parameter, then there is second one, which is the costing part, which is the utility consumption. So what are the typical utilities across the paint shop? In pre-treatment, it is the water. So what we thought is learning, implementing our learnings from other industries of benchmarking the specific utilities. So let us say I want to process one component of a paint, or a weight, 1 kg of a material of a paint. Okay, so we tried to benchmark it with respect to that material unit or kg. So amount of water required to process 1 kg of material, that can be benchmarked. So that can be measured as 1 liter or XYZ liter per kg of component to be produced. Energy, which is the electrical energy, kilowatts of units of energy consumed for processing 1 kg of material through paint shop. Similarly, for compressed air, it could be the meter cube of air or kg of air per kg of material to be processed. So this is for the utility, which is the costing aspect in pre-treatment. Similarly, in the painting section, it could be the air or material to be processed, which is meter cube per kg, and energy like kWh per kg. For the baking oven, similarly, LPG is the utility. So meter cube or kg of LPG or PNG per kg of material to be processed. So these are the utility related or costing related parameters. Now moving on to the most important part, which is the productivity part. So like the machine shop or foundries or any other operations that you have, it is very critical to measure the OE of the paint shop. I know it is very difficult, and we have worked tirelessly with many customers to develop a method to capture the OE, and that's where the loading, percentage loading in a paint shop can be captured, or the time between the two baskets if it is a batch process. So in terms of the baking oven, what is my percentage loading? That is another parameter. Okay. So these are the different critical parameters in the pre-treatment, in painting and baking oven sections for quality, costing, which is utility, and productivity parameters. I'm sure you will have the list of few more parameters with you, but yes, this and those can be relevant for the individual customers that we come across. Now, moving on to the next step, during our initial observations across this different manufacturing and auto ancillary industry, what we have seen is these critical parameters are measured once or twice in a shift. Okay, and that is very much true for tier 2 and tier 3 customers, users of Paintshop. So what are the methods that they use to measure these critical parameters? Very simple or basic methods like the litmus paper, the titration method to measure the concentration, the temperature gun or the display, and the pressure gauges. So as you can see, most of these are analog devices, and people can see the local display of that. Okay. Yeah. So if any of these parameters are deviated and ignored, it leads to a complete rejection or rework, hence a loss of man, material, and money. So just an example that if you measure the pH of a particular tank, let us say it is to be between 4.5 to 5, and you measure it at the start of the shift and you dose a chemical accordingly to maintain in that range. What happens till the next measurement over the period of 8 hours is, during the course of the production, this chemical gets depleted and your pH deviates. Because of this, you will see either a paint defects, and what it means is you had spent so much of man, material, and money from foundry to the machines to finally bringing it to paint shop, and just you are about to invoice that there is a rejection, and this rejection to the tune of 5 to 40% is a big loss for any company. So what can be done? What can be done with the help of this latest technology or the traditional technology along with the latest technology is you can use this IoT based system. So what is this system? This system, as you know, that Paintshop is amalgamation of different systems like Pretty, then baking oven, paint shops, and all of that supplied by different vendors. All of them may be automated. All of them may have PLCs, HMIs. But the problem is they are not talking to each other, and that's where the IoT system can play a good role. So what we are saying is your existing automations like PLCs or HMIs can come to the gateway panel. And along with that, based on our surveys and discussions that we have with your team, we can identify the pain points. The pain points could be solved with the help of some additional sensors like pH sensors, conductivity sensors, temperature sensors, weight measurement sensor, air or water flow sensors, and so on and so forth in the pre-treatment zone. Apart from that, in the furnace zone, it could be again like the weight sensors or the gas flow measurement or the speed and the kWh. And in the powder or liquid coating section, it could be again the weight, air pressure, gun program, and limit switches. So any of the sensors, additional sensors along with your existing system can talk to the IoT gateways, and from IoT gateways, all this data gets stored into your server. Either it can be in your premises or it can be on the cloud. And from there, you get to see the data. How you can see that data? You can see that data anywhere, anytime on your laptops, on your desktops, or on your smart TVs placed across your shop floor. So it could be the customized dashboards based on the industry type that you have. Some of that could be in the form of the reports or the trends or the live parameters. So this is not only on the laptop, desktop, or smart TVs, but you can see it on your mobiles as well. On mobile, what all you can see? You can see the live parameters. So for example, if you have a critical parameter, could be like, let's say, a compressed air pressure or a pH or a temperature of the bath. So you select that particular parameter and monitor that on your mobile as well. Not only that, if you're standing on a shop floor and the person complains that he didn't get a temperature or he didn't get a air pressure, so was that a real reason, and for how long that was the reason? Yes, you can see that from your mobile by clicking on the trends and see the last few hours of trend behavior. Not only that, you will not be in front of all these kinds of desktops and mobiles all the time watching this system. Okay. So just like you get a WhatsApp message or a money deduction message on your mobile and you open and you see that, this system also provides you push notifications so that if any of these KPIs deviate, like the pH, conductivity, or temperature, a person gets notified and he takes the corrective action on that. So this is how the system brings the user very closer to his assets whenever, whatever, in whatever perimeter he is, whether he is near to the machine or whether he is away from the machine. So how it helps is, it helps the customers to avoid potential losses in terms of productivity and efficiency. So what could be the benefits? Benefits is, sorry. And then he can use it for the root cause analysis, multiple trends, like one parameter versus second parameter and all of that. Quickly taking you through the case study for a particular aluminum casting industry that we had audited for 2 days to understand their process with the help of pH sensors, with the help of flue gas analyzer and few meters. What we understood is they had this offline measurement of critical parameters, and there was a big deviation that we measured for those 2 days. And then also there was a reduction in the productivity because there was no monitoring of the process parameters like the deep time and loading time. So what we did is we provided this system, and then with this system we brought all the critical parameters. We also provided new sensors like the pH, flow meters and pressures and all of that. And these displays were available throughout the shop floor. So what happened is, after that, customers started getting the alerts. They started getting this kind of unique batch report. So for every batch, they can get the batch number and they can get the product data. For all the tanks, they can get the critical parameters. Also, they can see what is my weight in that particular batch, what was my time for that particular batch, what is my water consumption and energy consumption. So much of data in one short report helps the customer to do the better analysis. And what it resulted is, it resulted into an improved quality due to timely draining and dosing of the tanks. It also helped the customer to improve the number of batches, that is the productivity improvement, not only into the print shop department, also to a previous department, which is the machining shop. So machining shop was giving the material in the right time so that customers can process, the paint shop people can process the products in the right time. And eventually we implemented this system across a few of our reputed customers like Endurance and Sigma Electric. So as you can see that the customers have not only benefited from the quality perspective, but also the traceability and the uptime. Going further, a customer at Sigma, a particular paint shop user, he has reported an improvement in the energy, water, and also the LPG consumption. And so these are multiple ways in which the customers have improved not only quality but also the cost aspect of it. And then that has helped the customer to achieve his investment within 1 year. What could be the other benefits? The other benefits could be the traceability, which can be used for the root cause analysis. And also for a few of the customers, we have seen that there is a debit that the end users put because of the faults. Now with this system, the customer can defend that my product is good. There is something happened during the transit or the end use. So a debit of up to 0.5% to 0.25% can be reduced with the help of such systems and data that you have. Cost optimization using the benchmarking and productivity analysis and improvements. So with this, I would like to conclude my topic, the first topic of this webinar, and I request the host to take you through our testimonials where we have our esteemed customer with us. Thank you.
Thank you, Milind. Nothing illustrates a use case better than a case study on how traceability, cost optimization, and productivity all can be achieved with IoT. The permutation and combination of key parameters was complex, but I think it's pretty important to understand because some of the other combination of parameters is common in every paint shop. And being able to see trends over mobile and alerts on phone. This is as simple as it can be to ensure faster adoption and leveraging the system in day-to-day transactions. Moving on to the next part of our webinar, it's such a great honor and a pleasure to introduce our industry expert and speakers for today. Mr. Ramesh Chavan, Senior General Manager of Manufacturing Engineering and Lean at Kirloskar Oil Engine, who is heading a team of 200 plus team associates, group leaders, and team leaders. He is instrumental in digital transformation at Kirloskar Oil Engine. Mr. Moreshwar Sapre, Senior Manager of Maintenance and Projects, Sigma Engineered Solutions Pune, who is leading by example what IoT can mean for maintenance and work order cycle tracking. We also have with us Mr. Sharad Jadhav, Manager Paintshop at Instron Technologies, who has been a catalyst in digital adoption of the shop floor at Instron. Mr. Ian Saldana, Managing Partner at Roman Standoff Autolab. Mr. Ian is passionate about the final paint finish achieved of automobiles, and this has led this firm to become a recognized vendor to every automobile OEM. So, to all the gentlemen here, my question is around your experience in the IoT, in paint shop specifically. When you proposed this idea, what were the hurdles and how you overcame it? And a story of when you look back, what are the key benefits? So these are questions which you can answer in any order that you like. Probably Mr. Mureshwar Sapre can start with. Over to you, sir.
Good afternoon. I'm audible.
Yeah.
Okay. Mauritius Sapre from Sigma Electric. What is the benefits of the IoT for Paintshop? That is the subject for today's topics. Now, why we are going for the IoT? Now, that one time is there we are analyzing the past data and then taking the actions. Rightly said by the Bill, the Paintshop is the special project. We cannot wait to do the analysis and take the actions to run the production, because this time we have lost lot of productions, lot of position, lot of cost on all these things. How we can come out of that problem? Now, how you are aware that the internet and IoT has taken place all over the world. Why we cannot use this to analyze all these data online? So that helps to do the online analysis, online monitoring, and online actions. Proactive approach is one of the key benefits of the implementation of the IoT. If we go with the IoT, we can take help of IoT. We can identify the problems that are potential to come, and we take the actions before that occurs. In our case, when we establish, we have art of facility of Paintshop. We have imported machines from Japan and all these things. We have set up Paintshop over there, and full automation was there. When we started the Paintshop, the process is a PT line, pre-treatment line, then drying oven, then powder coating, automatic powder coating, and then baking oven and then inspection. When we started our Paintshop, we are running with 3.28% of rejection. That was the equipment that we have invested a lot of on that to reduce the investment and have the high productivity. But due to various critical parameters, as rightly said by Millie in the presentation, that the pH, treatment line, then conductivity, then conveyor speed, temperature, all these affects the quality of the products, and that also affects on the productivity also. So we thought to how we come out of that, because when the old method is to take the data, collect the data, analyze the data, find out the root cause and take action. Still time lot of losses has occurred, and we can avoid this loss. So we had decided to go with the IoT. We have contacted to Instron. We have worked jointly. They understand our needs, process, and all these things. We sit jointly. We have decided which data need to be monitored daily basis, time basis, online basis, which is the important. And we have set this IoT system. Now, in our case, we are monitoring for PT line the conductivity, pH, then water level, which pump is on, which is off, whenever it needs, then automatic adjustment of the conductivity, that is the automatic filling of the tank, automatic draining of the tank, then how much baskets we have processed through the tanks, how much time we had deep the tanks, all these critical parameters which directly affects on the quality of the product we are monitoring online. So whenever we have set the limit for that, whenever one of the parameter goes out of the limits, it triggers the alarm. It will give the indications. It will stop the process so that immediately corrections can be taken place and further losses can be avoided. Same thing with the ovens. We are monitoring the conveyor speed. We are monitoring the temperature. So whenever there is a variation in the temperature, the process will stop. Alarm will trigger. So the concerned person will go there, check, correct it, so that the further losses can be avoided immediately. Same thing with the Paintshop also. The monitoring of the conveyor speed, the powder consumption, weight per product, we are on monitoring through the online monitoring. So that will help to reduce our reaction from 3.28 to 0.80. That is huge reduction in the rejection. The productivity will increase by almost 19%. Our utility consumption reduction by 6%. And not only this, apart from this, the working culture over there, who is working on that, they are very happy because online data they can see that data is monitoring on the screen. Their dashboards are there. So analysis is very important and immediately. So actions can be initiated immediately. That will help to sustain the KPIs of the paint shops and the reduction in the cost. That's all from my side. Thank you.
Thank you, Sapre sir.
Anybody else would like to share the journey? Ian, what about you? Yes, so Ian has a pleasant presentation. Mr. Sharad wants to share his inputs. Yes, Mr. Sharad, you are online. We can hear you. So the question was, how the IoT has been instrumental in your journey. What were the challenges you faced? What was the how you overcame those challenges? And when you look back, what were the key benefits?
Yeah.
Yes, sir, you're audible.
From Indra, I'm taking care of power putting and painting process for last 7 to 8 years. Hello?
Yes, we can hear you. Please go ahead.
Yes. जैसे अभी डिस्कशन हो रहा था इंडस्ट्री 4.0 एंड प्रोसेस पैरामीटर एंड केपीआई मॉनिटर with the help of industry 4.0.
Right.
So हमारे यहाँ पे liquid painting process में critical parameter, conductivity, then state of chemical parts, WD means water drying one and in power liquid painting, paint making for monitoring. But
Yes, we can hear you. Kindly go ahead. Everybody is listening to your inputs.
in the previous days, before introduction of industry 4.0, monitoring system, temperature डेविएशन के इंसिडेंट होते थे मतलब टेम्परेचर जो रिक्वायर्ड टेम्परेचर है वो नहीं होता था उसकी वजह से पार्ट के बेकिंग शेड्यूल में डेविएशन बेकिंग डिफेक्ट की बात आते थे वो अभी हम लोग आवर्ली बेसिस पे अगर थोड़ा भी 5 डिग्री से कम भी टेम्परेचर अगर वहाँ पे शो होता है तो वो रिफ्लेक्ट हो जाता है ऐसे एजेंसी करके ऑटोमेटिकली और मेरे मोबाइल पे भी एंड जो ऑनलाइन मॉनिटरिंग का स्क्रीन है उसको वहाँ पे
Okay, real time.
ओके अगर हम लोग को अभी हिस्ट्री भी एक चेक करनी है एक लॉग कंसीडर करके मॉनिटरिंग हमारे पास कंसोल के और पीडीएफ के जो हाईलाइट प्रिंटिंग होते हैं और उसका अगर हिस्ट्री में अगर कोई कोई आता है तो हिस्ट्री चेक करना रहेगा तो हिस्ट्री कौन सी टैक्स में कौन से टेम्परेचर को मतलब data भी हम लोग monitor कर सकते हैं। मतलब traceability जो है, process traceability, उसके ऊपर भी हम लोग most of it मिला।
Great. That's wonderful to hear the benefits that you have derived, and great to see that you are getting real-time alerts on the phone and you are able to take action immediately. My other question was, now आपने ये successfully implement कर लिया है, आप उसके benefits देख रहे हैं, तो आगे चल के आपका क्या roadmap है, आपकी क्या vision है कि आपकी factory में, आपके plant में
हम लोग liquid painting में 80% and painting में जो process है वो monitor कर रहे हैं।
जी
हम लोग अभी जो हमारा नया liquid painting का भी plant है और भी existing जो powder coating का नया plant है, वो plant में भी हम लोग ये process है वो already in process में है।
that's good.
जैसे हम लोग ये food के parameter paint food के भी parameter उसमें critical है humidity, बहुत सारे temperature, food controls उनके एप्लीकेशन के लिए पेंटिंग एप्लीकेशन के लिए जो क्रिटिकल पैरामीटर है वो भी हम लोग इमेज फॉर्मेट करते हैं।
That's great. That's great. Great to hear that with this success, you're replicating it in other plants, in other processes. And I think this is going to inspire many of the people from our audience today. Now, do we have anybody else who would want to participate and share their idea of their IoT journey? Or can I move on to the next presentation? Mr. Ramesh John, yes, he is online as well. So would you like to share your journey, when you proposed this idea, who were the takers, who were the challengers, what hurdles you overcame, what's your experience been? Mr. Ramesh John, I hope he's not on mute. Good afternoon, sir. We can hear you. Yes, absolutely. You are audible. Please go ahead.
Now,
No problem, no problem.
So I'm sure I'm not able to work for a second.
Yes.
So good afternoon to all. So I will
A
just
few thoughts over the Industry 4.0 and
what we are doing is focus on IoT limited.
Mhm.
So basically, the problem is distributed from the manufacturing facility. So here the major production is of diesel for the off-highway applications and opportunity sets with diesel. So Industry 4.0 we initiated this Industry 4.0 almost 3 to 4 years back, and we thought that the objective of the Industry 4.0 is to have a clear transparency of the data. The second thing is to have the decisions based on the data. And the third thing is
This is
to
my
have a clear improvement into the processes or the efficiency of the manufacturing processes so that we can get the benefit of the Industry 4.0. So these are the three objects we initially get in front of us, and we started working on the Industry 4.0. We have a vision of making our manufacturing facility as a smart manufacturing facility by 2025. So in that way, we have started working 4 years back. And we have adopted an approach of digitization first, then digitalization, and then implementation software. So these are the three objectives what we have, approaches what we have followed. And we have prepared a plan, almost 5 years plan we have prepared for this time. And we have started working on that. Initially, the team working with the plant has identified a few of the areas where we can make some kind of strategic projects. So as the objective is to connect with the suppliers as well as to connect with the customers, so that the customers can have a clear visibility of their requirement from the plant as well. And the plant will also have a clear visibility of the supplier. So overall, like this, we want to prepare the whole supply chain as a smart supply chain. from that perspective, we already connected with the suppliers and also connected with our customers. Now the whole process in the manufacturing facility at our plant is to be digitized, and that is what we have started working on 4 years back. As I said, the approaches of the three phases, that is digitalization, and business. Initially, we started working on finding out the projects for digitizing the workstations. For example, we have the insurance freelance, where most of the activities are done with a maximum continuous manual method, and the tools used for those applications are not giving us a freelance. So in the first phase, we started working on those areas and started digitizing those workstations. So like this, we have identified the areas like insurance, the stores, then the dispatches, the manufacturing processes in the machine shop, in the genset, and then the supporting departments like process engineering department, supply chain department, quality assurance department, all these maintenance and delivery departments. So all these departments, we had identified some of the projects that we call them as city projects. So almost more than 70 projects we have implemented successfully in the last 3 years time. So in that, one of the area we identified as a Paintshop. So why Paintshop? So Paintshop is, as you all of know, the operation is much critical as well as hazardous in some cases where the solid-based paints are used. The third thing is the product quality is again the aesthetic quality of the product is mostly dependent on the quality of the paint applied onto the product, and it is the first visible thing to the customer and the first impression of the customer as well from that perspective of the aesthetics of the product. So that operation we have selected, and we have selected, chopped down all the process parameters. The first thing is to improve the aesthetics of the product. The second thing is to have better control over the manufacturing of the paint process, so that we can have a clear idea about how the paint process is going on, whether there is any deviation, and we can find out the reasons, the root cause related to the paint quality. Once the data is available on the data. So from that perspective, we have started working on the paint shop. So we have a big paint shop here, wherein we process more than 200 inches per shift from the company's paint shop, and people are working with the manual spray guns there. So with this, we started working with the Instron Technologies, and we have decided to connect the paint shop on real-time basis. So the parameters like the pressure, the temperature, the air pressure, paint flow, the coolant, the washing temperatures, washing with concentrations, all those parameters we have started listing out, and all those parameters needs to be digitized first. So we put sensors for all the aspects of the process parameter and started collecting those parameters with the SCADA system designed by the Instron Technologies. With this, initially we have some hiccups while implementing, but after fine-tuning the whole process, we could able to successfully connect all the parameters on a real-time basis, along with the volumes produced per day on a real-time basis. So this has helped us to improve the control over the manufacturing process of the paint shop. So if any deviation into the air pressure used or the paint flow, the paint viscosity, then temperatures, the pressures of all the parameters, those parameters are now controlled better. Related training is also given to the operators there, and that has helped them to us as well. So we have put a big screen as well there, so that the operators also can see the screen and see the parameters, so that they can able to control over those parameters. And that has helped us where all the parameters are well within control. That has helped us to have an assured product quality, paint quality of the product. So that has eliminated many issues like paint rundown, paint overrun, all those other paint area is not painted. So like this, all the quality issues have got eliminated, and the paint aesthetics has improved. The quality and environment of the paint shop is also improved because all the people are not using very high pressure, so like for it, and the whole paint booth is getting clumsy. So like this, those are other benefits as well. Also, as we are tracking the output of the paint shop on real-time basis, we could able to calculate the efficiency of the paint booth as well. And accordingly, we have made some fine-tuning of the working methods in the operators that has helped us to improve the efficiency of the paint booth drastically and reduces our almost working. So there are many aspects of the digital initiatives which can help us to improve the efficiency of the processes. So this is one of the area what we are able to implement with the help of Instron Technologies. I think that is all from my side.
Thank you so much. This was wonderful to see and be a part of your 4 years journey, which started from digitization to digitalization and then the implementation. So, congratulations for building a charter, staying on track on your IoT vision, and I can see that it's in the 17 projects that you've implemented, right from the supply chain where you're connecting your stakeholders and customers. This is a very refreshing approach, and it is becoming an all-pervasive approach. I understand that talking down of all parameters is often complex, but thanks to the Instron team, this due diligence was conducted in full detail. So, and now with the HMIs, your operators can see and control the parameters better. We mentioned quality, cleanliness of booth, and efficiency of the booth. These are excellent examples that you have given, which are easy to understand for everybody. Now, moving on to our next speaker, Mr. Ian Saldana, Managing Partner at Roman Stand Up
Thank you,
for Life. We did give a brief introduction about him and his passion, which Mr. Sharad also mentioned about the aesthetics quality, in the paint shop, and that is something which catches the customer's attention. And I can see that Ian is equally passionate about the paint finish. I saw it on his LinkedIn profile, and that is his passion, and his that has led him to become a preferred vendor to every automotive OEM in India. So he has about 20 years plus partnerships with principal suppliers in UK, in Germany, and in Taiwan. Their projects division has successfully installed and commissioned paint circulation systems at many tier 1 manufacturers. In fact, these are customized PCS systems which are built to match customer requirements, which include equipment supply, engineering, and the complete piping for a recirculating paint supply system. So we would love to hear from you, Ian, on your journey, on your story. And I think the topic is reduce automation in paint shop to reduce compressed air consumption. Over to you.
Good afternoon, everyone. Thank you so much, all of you, for participating in this webinar. And I will take this a little forward in the sense that we are running short of time, I understand. So therefore, I would like to run through this quickly. To give you a little brief on Rowan Standox Autolac, we've been distributors for Binks, DeVilbiss, and Ransburg, brands that are owned by a company called Carlite Fluid Technologies in the US. And we have been their distributors in India since 1997. So we have quite a few years under our belt in terms of equipment supply. Our business is basically two different verticals. One is the retail vertical, which supplies the simple garage business across the country, for which we have 70 dealers who have been attached with us for the last 20 plus years. Moving into the second vertical, it is industry. And when you go into industry, you're talking about everything from simple manual spray guns to electrostatic manual spray guns to automatic spray guns. Then you have robo-based spray guns, which could still be automatic or bell guns. And the back end becomes the paint kitchen, Where we are going to focus our discussion today is going to be on the paint kitchen and the resulting saving on simple compressed air. I will go through a presentation with you, which I hope you will all be able to see on your screen. And all right, just to take you from slide 1, these are the basic utilities at every paint shop and paint kitchen. You have compressed air, electrical energy, your PNG, LNG, and water for your treatment plants. Moving forward, we are only now focused on the paint kitchen. This is where your paint preparation happens. In this particular case, we have taken a situation where we have got agitators and we have got paint pumps. We have not looked at any other further pneumatic consumption. There is lots that can be looked at, but I want this to be very basic so that everyone understands, even if you are using a simple diaphragm pump or a piston pump or whatever to drive your paint forward, the compressed air that you use is generated. It is an indirect source of energy. It is an indirect source of energy. Compressed air is today I think, one of our most wasted consumables across India, across the country. Now, if you look at what I'm showing you on this slide, this is a typical paint kitchen where paints are prepared. In this case, you have 32 tanks, agitators on those tanks, you have pneumatic simple diaphragm pumps. So this is primarily for tier 1, tier 2 and tier 3 companies. You are not talking about the OEM here. OEMs work on a different basis. Moving forward to the next slide. We have taken an example. This is a simple case study where we have got 32 AODD as an air-operated double diaphragm pumps, and we have 32 agitators for those materials. The consumption of all these 32 pumps is 105 CFM, that is cubic foot per minute of air, and for the agitators, it is 51 CFM. All right, so this takes a look at what is your consumption. These are kept in an always on condition because you have circulating lines. You do not want the paint to stand still. Maybe once in a week or once in 2 weeks, depending on your maintenance schedule, you will flush the entire line and you will recharge the line. So this is how it normally happens. This is the regular operation where you have 2 bar that's supplied to your agitator, 2.5 bar minimum supplied to your diaphragm pump. These are operating at your 2 bar pressure will give you X amount of RPM for your agitator, and it will drive your paint. 2.5 to 2.5 bar is what the AODD pumps require to drive your paint. Now, with automation, this is the standard. What you see in gray is the standard presentation. With automation, what we are aiming to do is to control the amount of compressed air consumed by the agitator as well as by the pump. Remember, these things are in an always on condition. If I can save 5%, it's 5% in my pocket. If I can save 20, so much the better for me. Now, the payback of these systems we have calculated is within a year. I'm giving you some highlights. Compressed air is by far the most wasted consumable across industries in India today. It is also an indirect source of energy, requires generation, storage, piping, drying, with air pressure losses at each stage. They say that there is an almost 50% loss of air pressure on every 90-degree bend in piping. Due to the high cost of electrical energy required to process all of this, and to get your compressed air, we can say if you are taking power off the grid, the calculation that is used is this is an industry standard calculation, is 1.6 times the cost of electricity for a unit of compressed air. When you go into situations like we have in Maharashtra, where lots of MIDCs run, or lots of factories in MIDCs run on generators when there is a power failure, at that point of time, the cost of compressed air becomes 3 times more or more the cost of electricity. So optimizing your consumption of compressed air will, of course, bring you a quick saving, a daily savings, as well as an saving of CO2 emissions. Let us do some very quick mathematical calculations. Sorry. the compressor consumption numbers that you can see right on top, electricity rate and the rate of compressed air, the rate that we have pulled out for compressed air, these are actually calculated. In the sense, we have run a compressor, we have checked the CFM outflow, and we have checked the kWh consumed. And based on that, we have come up with this number. Now, 6 rupees is at the bottom end of the charge that is normally charged to most industries. It goes as high as 18 and 19 rupees. All right. So we have taken this at a base level just to make you understand that your payback could be, in 50% of the time. I'm sorry. Payback could be in 50% of the time. Now, in regular operation with 32 pumps operating, the CFM consumed by agitators, each agitator consumes 1.2, 32 of them in this case study equals 51.2 at 2 bar operating pressure. Agitators, these are controlled at 2 bar right now, but they are constantly running at 2 bar. That also please keep in mind. The same applies for the wings pumps that we have presented here. These are 1:1 DX200 pumps, which are 32 in number. They consume 3 CFM, a total of 105, operating at 2.5 bar inlet pressure. So this is the pressure that you are constantly giving to the diaphragm pump to keep your paint in circulation. So now the total we have consumed is 156.2 cubic feet per minute of air. Multiply that into 60 minutes for an hour, into 16 hours. We have taken only a 2-shift day. All right. We have not considered this a 3-shift day because in many tier 1 and tier 2 companies, it remains at 2 shifts even now. Multiply that by 312 days, 26 days is what we've calculated to a week. 312 days in the year. The cost is in excess of 4.5 crores of rupees only on compressed air, where you are running 32 pumps and 32 agitators. Now, all that we are looking to do is to control the compressed air supplied to these agitators and supplied to these pumps. Basically, you need at any point in time, let us say all of these, for example, let's say all these are only in the base coat booth. I'm not complicating by saying part are primer, part are top coat, part are base coat. Let's say all of these are only being used in one single base on all base coats. You have 32 different colors. Now, in such a case, only one color is being applied at a time, whereas the rest 31 lines are all in circulation. They are all receiving the same amount of air pressure. Pumps are operating at the same amount of air pressure. Agitators are operating at the same amount of air pressure. What we are looking to do is together with Instron and with the IoT systems is to put these systems under a bit of control, where we have some kind of control through PLC and through pneumatic valves that will control the pressure of the line and the pressure delivered to the pump. We can have a preset pressure up and down. So as and when, let's say you are using color A and your next color is color B, we will have a program put into place where your operator will either hit a switch which says change the color. So you will automatically go into a flush mode. Thereafter, the next color will load and you will control the pressure going to the balance pumps. So only your pump in operation will receive its 2.5 bar, whereas the rest of them will be controlled and they will drop down to 2 bar. We are not looking at that big a control. It's only 0.5 of a bar. But look at what we are saving. We are saving 35 cubic foot per minute is saved. Multiply that by the same equation. 35 into 60 minutes into 16 hours per day into 2 shifts multiplied by 312 days. And your saving is over 1 crore rupees per year. So which brings us down to the payback, which shows you which are an approximate. We have just worked out an approximate for these 32 pumps and 32 agitators. Your control and your automation with PLC, etc., will cost you approximately 90 to 95 lakhs, which means your payback is in 10.4 months. This is not considering that you may be paying 17 rupees for your electricity. If you are paying 17 rupees a unit for your electricity, this payback will come down to 4 months, not 10 months. So just keeping that in mind, I wanted this to be the highlight of our discussion. Compressed air is something that is wasted very, very easily. The importance of compressed air is not even noticed. There are several factories that have even, after we have done this automation, they have even gone past into their piping of compressed air, stopped leakages because they have understood the importance and the value of compressed air. We leave this open for questions if any. I would like to say a sincere thanks again for your participation, and I will give it back to our host to take us forward. Thank you very much.
Thank you very much, Ian. That was a great process that you set up there. You brought out this spotlight on compressed air and how it can lead to quick ROI in daily savings, and not to mention the reduction of carbon footprint. You know, CO2 emissions are not just environment talk, they are closely tied to brand sustainability and brand value. Customers are now very conscious of the value in how a product is produced and what is the carbon load it is carrying. So kudos, Ian, for bringing in a new perspective and a paradigm shift in how each and every operation can be energy optimized by considering minute details such as compressed air, electricity. The PLC controls can give you a payback in crores. Wow, that was mind-boggling. And money saved is money earned. You know, this is a good principle. So thanks for sharing your recipe with all of us. Now we are moving on to the Q&A section. And any questions, please feel free to type in the chat box. We do have a couple of questions. So let me start with the first question that we received, which was on why measuring pH is important in Paintshop and what should be the ideal pH.
Yeah. So, hello, I'm Milen. So I'll take this question. So even though I'm not from the process background, but just because of the experience that I have gained with the reputed customers like Sigma, Endurance, and Kirloskar, and many more. The reason why I see pH should be maintained is so it's like the work that you are trying to do in the pre-treatment is cleaning of the components before it is coated with the liquid or powder. So the cleaning has to be done for thoroughly for all the oil or the smudge or the dirt or the burr that you have on those components. So if the pH or the conductivity or the concentration of the chemicals are not maintained in a predefined range, then what it does is it doesn't clean the components. So if it is maintained too high or too low, that is also a problem. Okay, because if it cleans too much, then it may lead to a blackish or the some marks on the component. So from the aesthetics point of view, yes, all these parameters are important. Now, the second question is how much should be the pH? Yes, that's a detailed question. I'm not the process expert, but the consultants or the process experts working with you can give the answers to what this could be. And if not, then you can always talk to the OEMs who can help you connect with that. We have some process experts who can help on this as well. Yeah. Thank you.
The other question is what kind of real time is helpful in improving productivity?
Yeah. So this question I'll request Mr. Sapre from Sigma to answer because he is the one who has been using and instrumental in developing this system. So I request Sapre sir to share his views on this question, how the productivity can be improved with the help of this system.
The real time data.
Real-time data is important to improve the productivity because when you notice that the conductivity is increased or pH is going down or up or something that, and you have to take the shutdown of the plant, you have to drain out the tanks, you have to prepare the chemicals and then again load it and then maintain and then you can start the operations. So a lot of time waste in that process. So this is the nothing but loss of the productivity directly. If you going for the IoT or you are monitoring online, whenever you know that the pH is going down or conductivity is going high or down, you can automatically drain the tanks, fill up the waters, maintain the pH conductivity online. So there is no need to take shutdowns or no need to stop the production. So you online maintain the parameters, and that you can save the lost time and improve the productivity. Thank you.
Thank you, Suppressor. Along with this, there could be one more thing that customers can do is like the material that you receive from the previous departments, like the machine shop or the quality test in process quality. You can highlight that this so and so batch or so and so process is about to get over, so I'm ready, I'm hungry for the material. So by alerting the previous departments also, you can save the lost time in terms of the loading and in terms of putting the components into the basket. So that could also, like, very simple things can also help you improve the productivity. I hope we could, Suppressor, and we could answer the question.
Yes, I believe you've also answered the question which somebody asked about monitoring parameters like pH and how does it help increase productivity. So you have actually answered this question as well. There's another question that we have. How does an IoT solution help to minimize utility consumption? So I think this is answered by Yan. How and he would like to answer it in further detail.
I will again answer this specifically based on the paint kitchen or your paint shop. Now, in this case, we are talking, what are your utilities? Your utilities are water, electricity, compressed air. These are your base utilities. I am asking you to focus on compressed air. There is lots of automation that can be done. But as far as compressed air goes, there are several things we can do in terms of controlling the amount of compressed air used by the equipment. And all of this falls under the, all of this again is IoT based and is PLC based. So you will have screens that all over the plant, they can be connected with your current SCADA systems, so that you have data from your paint kitchen, from your paint line, that is, real-time data given to you. It could be a simple thing like even refilling your tank in the paint kitchen. All right, this is something, it's not related with compressed air here. But if you drive your paint, you need to have a certain level of paint in your tank. If your paint tank level falls down, your agitator is going on rotating, your paint tank level is at the bottom, you are driving air into the paint and drying the paint. This will cause you flaking and it will cause you paint quality rejections. Now, paint quality rejections means the complete component is rejected. There is nothing that you can do once the component is painted. So in order to monitor all of these things, you need to have this kind of automation, which is, we are in 2023. This is what is happening all around us. We must be aware and we must make use of these systems, especially when we have continuous production processes. I hope I have answered that in terms of paint related queries.
Thank you, Ian. Over and above that, so that was about the compressed air utility. There is one more utility that we have worked significantly, which is the fuel which is used in the baking ovens or the water drying oven. So it is basically the combustion that is happening to heat up the fresh air and hence to raise the temperature of the component. What happens is these booths are always ignored. The combustion tuning is never done. Because of that, if a particular operation requires only 10 kg of gas, it consumes 15 or 20 because it's never monitored, it's ignored. And that's where these systems can help you benchmark that for so and so kg of production, I consume so many kgs of gas. And if you observe this performance over a period of, let us say, 30 days, obviously on some day if there is a leakage or any deviation in the burner performance, this can be highlighted. And as a part of like this group that collaborators that we have, wherein not only the sensors but and the automation, but also the basic components like the paint related equipments, as a team we can do the audit or the observations of your plants, and we can help you identify what could be the areas of improvement, and we can also propose the phase wise implementation of such systems. Okay, so I hope we could answer. Mr. Sapre also wants to share his views. Thank you, sir.
The saving in utility can be achieved only by monitoring the utility consumptions per parts or benchmarking of the utility consumption. Whenever you want to save, initially you want to monitor first, but the utility that section will not go in that details to monitoring by part base or hourly base or minute base and all these things, because we have not the accessories or tools that can monitoring online consumption of these things, and the wastage cannot be come in the surface. So it is better that you monitoring online, that you can identify that. For example, in PT line, If conductivity and pH is there, but as a ritual process, we can drain in the tank. There is no necessity because conductivity and pH is maintained. You can go for second shift also, but it is ritual. SOP is mentioned. You drain it, so that is the loss of utility. Same thing with the ear. Whenever you don't require the agitator, you can switch off the agitator. When your production is off or you are doing the tank preparation, you can switch off the this. When you monitoring this, when you know this online that is running, but our production is stopped, you cannot pay attention over that, and that gives the saving from 3% to 10%. So that is important for utility perspective. Thank you.
Thank you, Supress.
Yes, idle runtime of machines, sometimes that is not noticed or monitored. So I think definitely it permeates to different processes and machines as well. We have another question on traceability. How traceability is done in the paint shop?
So I'll try to answer this question. So before that, why the traceability is required? So when the components are painted, and yeah, obviously there will be an in-house quality check, but sometimes the quality is missed and the end customer rejects some of the components. And to know whether the reason for that was the vendor or there was something happened after the dispatch. So in such cases, the traceability is required. So what all could be traced? Whatever the parameters that are important for achieving the desired aesthetics of that particular component. So what are they? So that could be if I want to go further back side of the paint shop. So it could be starting from the foundry, like what was the mixture of the fresh ingots to the scrap or recycled scrap, because that mixture is also predefined and that is helpful for achieving the desired performance. Not only that, what was my melting temperature? What was the machine? Which operator used it? And then coming to the paint shop in a particular tank or in a particular basket, what was my pH? What was my temperature of the bath? What is my conveyor speed? What was the compressed air pressure for spraying a particular liquid or powder on that component? So all these components, all these parameters are very important to achieve the desired quality of the paint, and this all can be monitored and included into the traceability report. Okay. It always depends on what are the pain points, what are the essentials for particular customers, but yes, there could be a starting point with few of these parameters, and then as you start realizing the savings over a period of time, these systems are flexible, upgradable. So this year I put 5 parameters, I get the benefit, I reinvest that savings into further few more parameters. So that's how the systems are growing. So I hope I could answer the question on the traceability. Thank
There's
you.
another question on integration of the Paintshop IoT with ERP for production planning. So I think since it's about ERP, I can confidently say that ERPs can range from anybody using a Tally or a Odoo or a SAP or an Oracle ERP. And they all of these have APIs which are exposed. So the Paintshop IoT, the solution from Instron Technology, is modern, is able to expose its APIs and work closely with the manufacturing modules or the production planning or the MM or the the maintenance modules, sub modules of ERP. So the short answer is yes, it can. And I've already given the detailed answer that irrespective of the ERP or the technology stack it's on, the integration is very much possible. We have one more question on what is the ideal ratio while preparing a paint thinner ratio. So somebody wants to know the secret.
No, it isn't a secret. See, every paint comes with its own technical data sheet. Now, especially in a production environment, you can never do this by rule of thumb. You must go by what the technical data sheet suggests, especially in places like Pune, where we have a bit of extreme climate. You may have temperatures going as high as 45 degrees and as low as 4 and 5 and 6 degrees at some point. Now, if you are operating at night and it is 5 degrees outside, you may need a different ratio of thinner to paint. Why is that? Because your paint is now thicker because the temperature outside has become cold the paint has automatically increased in viscosity. So therefore, you may need more thinner. Similarly, during the summer, it's 45 degrees, it thins the paint automatically. The paint becomes thinner because of the heat. So the viscosity goes down and you will need less thinner. But refer to your technical data sheet. Don't go by rule of thumb. This is a problem in every paint kitchen, every small tier 1 and tier 2. They do not maintain TDS-based mixing ratios. And this becomes a huge paint rejection problem. Especially if you're painting plastic parts. Please be aware, go by the book. Do not go by rule of thumb. Because plastic parts, once you paint, you have to destroy. There's nothing that you can do to recover that part. Thank you.
Very, very technical and detailed answer. And on a lighter note, I think women know that instinctively when we paint our nails, what's the pH, what's the humidity outside, and how
The
much
ground
thinner we
coat, what's the
need to
ground
be.
coat and the top coat?
Right. So that was on a lighter note. And we have, I think this question was already answered on the it's a repeated question. So I think with this we come to the end of Q&A session. We would love to hear more questions. You can reach us out to Ekta Upadhyay at 9623424000. Yes, we have one last question. We will take this. What's the difference between water drying oven and baking oven?
Water drying oven normally used after the pre-treatment lines to dry the parts fully. The temperature of the drying one is lower side compared to the baking one. In baking oven, we have to bake the powder or paint, whatever there, depends on the technical data sheets you have to maintain. So as a design, there is no difference. Only difference is keeping the setting the temperature over there. For drying, maybe you require less time. For baking, you require more time, more temperature. That is the difference only.
Thank you, sir.
Thank you. Now with this, we conclude the Q&A, and to summarize our session, my takeaway is from the discussion is that manufacturing industries and especially Paintshop, this accounts for almost a huge chunk of operating expenses, almost 15 to 25%. So apart from quality, one needs to keep a tight check on controlling cost. So IoT in Paintshop can exponentially, in fact, I saw that with the use cases and case studies that it's almost doubling up the benefits. It's been a great pleasure to be hosting the key speakers and presenters for the webinar today, and it has been a great learning experience as well. So, and thank you, dear audience, for your precious time and patient hearing and the very inquisitive, good questions. Before we conclude, we are offering a one-on-one consultations and advisory for your requirements. So please feel free to reach out to us. You can drop us an email or a message. You can visit our website. You already know the Instron team as well. So this consultation and advisory is free of cost for the lovely audience here. So thank you for your time and have a good day ahead. Thank you.
Thank you.
Thank you.